This is a Honeywell inexpensive thermostat that I purchased 3 years ago, and it's been serving as the backup for the thermostat that I've been designing for the last, I don't know how long, 2 years now. It runs in parallel with it, so that if for some reason my thermostat doesn't operate, this will at least kick on the air conditioning or the heating if it gets to be way too cold for the heating or way too hot for air conditioning. And I came home one day and saw that the display was off. So it was completely blank. And I thought, that's interesting, because it didn't indicate that it had low battery or anything like that. Not that I check it that frequently, but it doesn't run much at all. Maybe that plays into it. For whatever reason, it didn't tell me that the batteries were depleted, but then the display was off. I found that interesting, so I popped it off the wall and found that the batteries that were in it, which are not these batteries, these are Eneloop Pro batteries, which are just temporarily in it. They're not usually what I put in there, but I had a handful of disposable AAA batteries that came with some remote controls for various things, and I don't like having them around. I try to get the rechargeable batteries into the remote controls because they're less likely to leak, and if they go dead, whatever, I just pull them out and recharge them. I took 2 of them and put them in this thermostat. When I took the cells out, let's remove these now. When I took it off the wall, flipped it over, I noticed that one of the cells was leaking. And these cells are not that old. They are at the oldest. The cells are 2 years old. Took the cells out, threw them out right away, so I don't have them anymore because they were leaking pretty good. And so you can see that some of it has leaked down here on this identification label. And I thought perhaps that's as far as it went. But then I put these batteries in, which are charged, and figured I'd just use these Eneloop Pros for the time being. Put it back onto the wall, and then this started to happen. So I don't know what that is. It seems like that the batteries had leaked more. They may have been dry cell batteries. They may not have been alkalines because they're really cheap for like remote controls and things like that. They may have not been best served for use like in a thermostat like this. But whatever. They shouldn't have leaked. So anyways, it started making this crackling sound. It started heating up, which you can see in the thermal images that I captured after I had it on the wall for a while and took it off. There are no shorts on any of the pins that I could see from on the wall. I haven't checked on this side yet. But what I thought I'd do is I would open it up. You can barely see on the silk screen here what the connections are. And then I get the bench supply, which is DC, but this isn't going to care because it's really passed through, to see if we can get any indication as to what is going on. That creaking and cracking sound to me sounds like capacitors failing or swelling, which probably means this is not going to be usable anymore. I did managed to get it to turn on the air conditioning and the heat, but I wouldn't trust this thing as far as I could throw it now. There are 4 clips, 1, 2, 3, 4, that hold this back piece on. This is not a mains referenced supply. This is just talking to a standard HVAC controller that's got a 24 volt transformer on it. Oh, looks like I just take out 2 of them and then it just slides out. Okay. Okay. Not too much going on here. Here are the connection points. This is for the switches. There's just a single relay, but it's a single pole. Geez, I think it may have 4 throws on it, which can go between various things. This is a single stage controller, so it's not meant for it can control heat pumps and other things like that, but only in a single stage, as far as I remember, because the second relay here is depopulated. And the reason why it's just one relay with so many different throws on it, so it's a single pole and it's switching across, actually quad pole, quad throw, I think, because it actually switches across 4 pins whenever it's turned on. And so what it is that the connection points are switched. Like when you flip these switches between gas or oil or electric or heat pump, or you want the fan on or auto. Auto will just turn this on, but then bypass. Oh yeah, this switch will just turn the fan on, short out the connection that would have been used for this, for automatically turning on the fan for air conditioning related things. The heat and the cool just switch between whether or not you're in, which tap on the relay you're connected to go through to this, to back to here, because this is all looping through to a 24 volt AC connection point that's on the furnace controller. It comes through here, goes through the switches, and then goes back through to one of these 4 or 6 connections. I'm looking here now, and it does look like there's a little bit of like skid marky stuff on the board, but that looks more like it looks as though it's more solder mask. As you can see right there, there's some marks on the board that look like there's a little bit of burning on there. And in the video, you could see that the temperature was being reported as like 90 degrees Fahrenheit and climbing rapidly. There's a little thermistor in the corner, and it's got notches to kind of give a lot of air to pass through and to thermally isolate it as best as possible. And there's no components on this side. And there's probably no copper underneath it. Nope, it looks like there's no copper. There's no fill on this board really at all. It's just traces and no ground plane fills or power plane fills. Interesting. I don't really know what happened here. But let me see if I can remove the clip here and then pull this circuit board off. And then we'll hook it up to the power supply to see if we can spot any heating to locate what's causing whatever sounds this thing is making. This side looks clean. Oh, wait a minute. What is that? Wow, something is that? No, it's on this display too. I think that was actually some acid. There is a ground plane on this side, but they remove it here, put those 2 notches in, and then there's the thermistors on the opposite side of this. So pretty good layout to try to minimize any quiescent heating. What are the pinouts here? RC and R are actually linked together at the wall. So I may have to test both of them individually, or I could jumper them together. I'll just test them individually. So RC, we're gonna grab that there. And then I'm just gonna go across here and check. Yuck. Half a megohm. Because if I look at that and then go to G is fan. Wow, it's really acting funky. So R we know is 24 volt power. There's 2 power points here. Yellow turns on cooling, W turns on heat, G turns on fan, C is the 24 volt common. Oh, right, there's no common in this system. This is a 4-wire system, not a 5-wire. So common should have some, it should be pretty, what? That's weird. What about this one in common? Okay, so that's better isolated, but it's falling rapidly. I don't know what's going on. So let's go back to, I think it's this one, and it jumpers to both. R is what we want. And then there's R cool, R sub C. I believe that's what that stands for. So R for heating, let's just check heating, which would be W. And it's not on right now, so that should be very high impedance. Not great. 100K? No. And then the other ones, Y, should be very high impedance. 6 megohm, okay. Should be higher than that across that relay contact. And then G is the fan. Wow. Well, I think this thing is toast. I'm going to plug it in to... Let's just have some fun with it, basically. The power supply powered up. And this is DC, but it doesn't really matter. Nothing is powering the circuit. It's just a pass-through from into to back out of the circuit. So all I want to do is just get the equivalent of 24 volts AC, which is about 30 volts, 33.6, but the supply only goes up to 30 volts. So we're just going to go up to 29 with a limit at 29.0, and then we will limit it to 1 amp because that's what the furnace controller would say, I think it says only see 24 VA. So this would be basically that in DC. So I'm going to do 24 volts on RC, and then I'm going to connect to cooling while cooling is off because it's not turned on. So we're going to go to Y. That's Y right there, right? YGOB. Okay, so there we go. You can see it. The two alligator clips connected there. And when I turn this on, I should get no current draw. I should get really nothing. And we're getting 31 milliamps. It's fluctuating. 1 watt being passed. So we're at 29 volts. Oh, there's smoke. There's smoke coming off of there. Wow. That's just the board? What the hell's going on? Oh my God. Something's really getting hot. And it's not even that much amperage. That is very interesting. I don't see any indication of how, unless it dripped down the plastic here, this lip, and then it landed right on top of this. Now it's time for the thermal camera. As you can see, that there's a lot of heat appearing. Oh man, 5 watts? 150. We've already exceeded 150. Oh, and it smells like burning. Where is it finding that hot spot though? I think it's right. It's in multiple places. We're at a half an amp. No, 1.1 watts. It's not that many. It's not that, the wattage isn't that high. 2 watts, back to 1. It smells burny. Oh, it's burning in another spot too. I wonder if that's actually battery acid that's burning, which is probably not great to be breathing, but let's just test between R and heat, which is W, which again is not turned on. The device isn't even turned on, so the whole thing is open circuit right now. And if I turn this on, so, jeez. It's not drawing that much current, but it's 1.2, 1.4 watts. That's a lot across. There should be nothing on this board is designed for current carrying because it's just signaling 2.4. It's all over. And you can see the smoke again. Something is really burning. Wow, let's see if I can get really close to that. Yeah, I think that is all. Oh, I think there's some arcing going on too. Yeah, that's not good. Well, let's try something. You can see how terrible this board looks. Okay, that's just more smoke. Yeah, that's pretty terrible. So my guess is that it's not the grease that's on this, because that grease is non-conductive. Or is it? Did this grease? No, it's been on the wall for so long. So I'm going to clean this off with some isopropyl alcohol, whatever this stuff is, as best I can. The vias are right next to each other because, again, it's 24 volts AC. It's super low voltage. It's actually smoking. Look at that. Look how black that is. Jeez. Wow. I'm going to clean up here as well. Maybe it is from the battery. Again, because of the way that this thing is created, that if it's got a cutaway here, and then it dripped down. You can see where it dripped down here, went down inside here, and then leaked inside here. So that's why it was kind of like spread around here, I guess. So let's hook it all up again, now that we've cleaned everything off. Cooling goes to cooling, which is Y. Again, it's not connected, so we should see basically 0 here. All right, so that should just go to... Still drawing current. Why? Oh, is it down below the... Oh, geez. I think it's down through this switch. I'm gonna bump it up to 2 amps. It's not close, but I don't see it going into limiting mode. Well, that blew clear. Nope. Now it's current limited. Phew. Holy shit. Well, I think that's about it. I don't know what happened there. And it's sustaining an arc at 2 amps. This has gotten very interesting. Let's take a look now where that chart itself, the power supply, is off. Oops. See if we can see anything going on. I don't know. I think it leaked all the way down underneath this. It's interesting that we cleaned this area up and then it moved down to another area. Let me get a little bit of alcohol. Let me just pour some alcohol in here and just see if I can get it to go underneath the... Please don't do this to your electronics. Just enjoy the entertainment. Don't do that, because you can damage stuff, especially like electrolytic capacitors or other passives that don't want liquid like alcohol just being run through them. Man, I am stunned. Okay. Well, I feel like the batteries leaked, but I wouldn't have expected this kind of a failure mode. Go to R, C, and Y. Let me put it the other way. I'm gonna switch it back down to 1 amp because I'm nervous. Still drawing way too much current. Now it's up to half a watt. No, it's climbing again. I think it's gonna start smoking. Probably. Let's increase the current limit to 1.5 amps. Let's see what happens. 2/3 of a watt, 0.8. And we're climbing. Something's gonna get hot enough to start smoking again. Again, this should be open circuit. There should be nothing here. But we're up to 1.1 watts. The wattage keeps going up. Then it goes back down again. Then it comes back up again. I smell it. I see little wisps of smoke, but nothing like before. Let's increase the, whoops. Yeah, let's increase the voltage to 31 volts. That's the maximum this power supply can go up to. So the potential's a little higher, a little closer to what I would actually be seeing at the wall as far as the voltage RMS. But again, remember, it's DC volts versus AC. Still very high. It should just be open circuit, no current flowing, not 20 milliamps. Okay. Yeah. Let's stop and we'll try the, turn this in the standby, switch to heating. That's heating, and heating is W. You know, and while we're at it, I'm just gonna make this interesting. I'm gonna take a little bit of this just to make sure that it's not this goop. I'm just gonna wipe a bunch of it right here, right around where the other one started to arc. There we go. So I've just wiped some of that grease that I think they consider, I think it's conductive grease. I'm just gonna wipe it right there on those traces. 2 watts. And then dropping back. Smells. That seems to have backed off pretty quickly. Yeah, here we are at 186 milliwatts, 155. Dropping back. It's still passing current, which is not good. 4 milliamps, 5 milliamps. Let's switch back to RC and Y one more time. And I want to see if it, jeez, oh jeez, it is that stuff. Check that out. I wonder if the grease got in there or it's a combination of things. Tried to fix it. Oh well. So this is what I was hearing in that original video, that like hissing and clicking and popping. Jeez. You can see underneath there. But it's more like it's inside the switch. It blew itself clean. Finally, it's showing 0 amps, 0. Nope, now it's back again. Unbelievable. But there it is, 0, but it keeps jumping up every so often. That was with a 4 amp current limit, by the way. I feel like one of two things have happened here. The grease, which is put on these pins to help with this thing mating and disconnecting from the wall, somehow got pushed down too far, eventually hit the vias that they put really, really close around here. So here, over here, and over here. I'm just curious, can acid, like, you can see that it leaked here. It leaked through to here. I didn't see any indication of it going down inside though. I would have thought it would have, because it's on the wall like this. So if I flip it this way, we'll just pretend the wall is, you know, is now facing down. That it would just go down this way and then drip down onto here and then perhaps go this way. Maybe that's what it did too. Maybe it did in both ways. It dripped around through here to the top and then down through here in the bottom. But I don't see any indication on this lower lip of any battery leaking or any acid. I'm perplexed. You can kind of see the hint of wisps of smoke. Rub my finger on this. That comes off. So there was smoke inside here. I guess I just didn't see it. But yeah, if you have one of these and it starts acting up like this, yeah, I'd probably replace it. So if you hear your furnace kicking on and off, or you hear the blower kicking on and off, and like random things kind of cycling on and off, and you hear this sound coming from your thermostat, and you may have used batteries that leaked, it's not a hazard to your furnace or your air conditioner, but it could cause expensive repairs for short cycling the compressor on your air conditioner, high rates of cycling on the furnace controller, the gas control valves, or other things depending on what configurations you have. So let me know what you guys think happened down in the comments below. And as always, thanks for watching, and I'll see you in the next one. Take care.